two-bladed systems are still the most prolific rotor system on the planet. Jet Rangers, Hueys, Robinson R44s, those are the three biggest products that have ever been built, the largest volume products. And I think if you consider those as all two-bladed setups, it's hard to...
Plus, it sounds cool.
It does. It makes a great noise.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
All right, hey, welcome to the Hangar X podcast, and we're here live at Verticon, and this is a place where we get to interview innovators, disruptors, and the thought leaders that are actually making the changes in aerospace happen, and we get to hear the news before the rest of the world. And I'm here with David Smith, for the CEO of Robinson Aircraft, and I've been very excited to have this conversation with you, because not only am I going to learn how to fly a Robinson this year after 30 years of flying, but some of the announcements you've had here, and I'm looking at your technology, and I actually got to go over and talk with some of your senior design engineers and aircraft engineers and really go a deep dive on the 88 and the 66. And but love to just hear from you, kind of where's the state of Robinson right now?
Sure. I mean, we have a one-of-a-kind recipe at Robinson that produces the most weight-efficient vertical lift vehicles in the world. That includes our now integrated Ascent Aerosystems unmanned systems as well. So we build drones out of the Torrance factory as well. And they're little helicopters, coaxial helicopters, but they are nonetheless helicopters. No collective, but they've got cyclic control and splash plates and all that. But it's a great recipe that produces the most efficient way to get something lifted, dollar per pound, and just horsepower per pound. And I think in addition, it's an American-made product. These components, from raw material to the finished aircraft, are all built in Torrance. We depend so little on supply chain that I find myself having less things to get frustrated about, but I do still get frustrated by anything I have to buy, because no matter how good the industry is at producing, we faced this disruption of these last few years that it paces all businesses, but we are better set than most because so much of our work is done in-house. Things like hydraulic components, we grind and machine, mill, and lathe all the components in our servo actuators for the hydraulics, all the reservoirs and pumps, and we build much more variety of parts than our competition does. And that's been a secret to our success for a long time.
Yeah. How about ball bearings?
So I wish we did ball bearings, because that was the thing that paced me last year,
right.
Ball bearings in the engine. But no, that's a dying skill, the ability, and it's needed in advanced air mobility just as much as it's needed in conventional air mobility. I think the need to build, both the ball elements themselves, which happened to be the pacing item last year for us, but sometimes it's the complicated assembly of the races and all that tend to be skill we don't emphasize to school kids, and we should. We should talk about castings, forgings, the complexities of metallurgy, all that stuff. It is not going to be a carbon world. It will have carbon fiber, that is. It will be a heavy metal world, whether we like it or not. It's still an important ingredient in all
things like gears, ball bearings. You got it. There are certain materials you cannot use.
That's right.
That doesn't work.
There's forgings and a lot of these landing gear for these types of new advanced air mobility vehicles, and you're not going to get away from forgings and castings and the like. Weldments, Another one. Weldments are in every motor on every one of these things. And welded structure and welding inspection are incredibly important technologies that I wish as a kid that someone had told me you can make six figures as a non-destructive inspector. Maybe that some kids wouldn't spend the money on college and go right to work.
Yeah. We definitely need more people coming up in the trades here.
Yeah.
In the U.S., but I'd love to share about your vision. From when you came into Robinson.
Mm-hmm.
I've been hearing about Robinson for a long time. When the 22 and the 44, I was always just fascinated with the helicopter. And I was finally able to ask yesterday, why do you guys have such a long, post on the top?
Yeah.
Because it's a very unique design feature, and I never understood it before. But could you maybe share a little bit about the design philosophy behind Robinson?
Sure. First, Frank started everything off with the idea that he wanted a personal helicopter, one that he could own, he could easily fit in the world around him, so parking spaces and parking garages, and have them at the ready to get him to and from and over traffic and places that we all just drive past. The lakes and rivers of the world are beautiful, and you can't get to them easily without hiking there, and a helicopter can get you there in a moment, right? So I think he saw that, and so the design approach was always about keep the efficiency of the product and the ability for it to be maximum economics efficiency as well, were just essential ingredients in it. So he thought super carefully about the types of technology involved. He could have done a multi-bladed rotor. He knew about those things. He selected the two-bladed rotor system, as we did again on the 88, because they are robust in many ways that are not the case in some of the multi-bladed setups. They have some fragility to them that you have to be thoughtful of in service.
The two blades do?
No, actually the multi-bladed do. So when you consider almost every multi-bladed rotor, both on the way that it integrates with the airframe for things like ground resonance, you get complex oleos and struts to balance the landing gear and dynamically tune it. Those things are exposed to the environment and degrade and can cause other problems in the wear and tear of the aircraft. The same thing in the rotor dynamics. You get elastomerics and rubber that there's only a handful of providers that do that work. So you get constrained in who can provide it. And then you have these slow progression problems that can lead to wear and tear on aircraft and breaking of critical structure. So there's every aircraft in the industry during their development and then in fielding has had cracked tail booms, cracked structure. Those are dynamic phenomenon, oftentimes coupled into rotors and elastomerics. And I'll tell you, Robinson, you go look at our tail booms, there's no doublers other than the initial structural doublers. There's no repair doublers on ours. So some of those things are because Robinson's products are intentionally simple and the designs avoid some of the pitfalls that unfortunately plague modern high technology level aircraft, but maybe aren't, in the end, they aren't robust in field and they have many, many follow-on trails of logistics and repair and teaching people how to do hot bonding of doublers and things that tend to be messy, field practices. So our product are bulletproof in many ways. We put them on, fishing boats out for a season of tuna spotting, and they live a whole season as a mission critical element of the crew. If the aircraft goes down, they can't find fish. So that's a mission critical role that our aircraft are uniquely qualified to do. And they come back and it's amazing what they can put up with. You see sand blasted, salt blasted, masts, hubs, components, and they do a great job. So, I mean, that's part of what the philosophy is that we never wanted to leave things to a maintenance technician alone to have to make assessments of airworthiness. So good example, we want it to be time limited parts, time life parts. So we have more components that come off of our aircraft, which makes it very predictable. So it's not ambiguous at all when they should be removed. Whereas in a lot of cases, folks have gone down this road of on condition, where you have complex inspection in the field to evaluate, is it good enough to stay on the wing? That just adds maintenance time where you have inspection and the like. So the philosophy.
Also, it was interesting yesterday talking to one of your engineers about the rotor head fixed versus floating.
Sure, yeah.
In the fixed head has a lot more torque, which probably puts a lot more wear and tear on the body.
Mm-hmm.
But the design you came up with also has less parts, which I would guess makes it less expensive, but also easier to maintain and more reliable. Is that fair?
That's exactly right. And a good example, even for our two-bladed design, it's unique amongst all two-bladed designs. It's the latest two-bladed design in certified aircraft. And it was removing a lot of the rubberized parts, just TT straps in a lot of the existing two-bladed setups, which are basically rubberized, wound metal so that it can take tension and torsion motion in the blades. Our designs use simple roller bearings, back to bearings. You have to have good supply of bearings to do that, but it takes a lot less of that load in a structurally flexing member, so it's not subject to fatigue and failure. Unfortunately, we had a couple of failures in the last couple of years with TT strap failures that had blades depart the aircraft, And I think in our designs, we don't feature those types of things because they have these failure modes we don't like. So our bolted joints are much more robust for field support, easier to observe and look at the torque stripes from the ground. You can see them, verify that they're all properly torqued. That's quite good. His design as well, when he went in after the hub, he saw that many of the other aircraft used the blade coning action, which is one of the natural phenomena of these hubs. They used to take these in blade bending, which ends up taking a paper clip and flexing it enough times to where it might break, right?
Right.
So we decided we didn't want to have that, so we put a coning hinge point in there, and that has allowed for these blades to last longer and be, when they come back to us at the end or when we look at them at the end, they could go longer. We don't extend the life because the airworthiness long term, it's better to keep them coming out of the fleet every 2,000 hours or 2,200 hours for the 22 and 44. But you do a much better job on airworthiness to have a predictable outcome. Pull the part off at this hour, and we'll get them another blade to put on the aircraft soon after. We built so many blades that keeps the economics low too. You think about how scaling happens, right? So
yeah. Well, and you were talking earlier, like every part of the entire assembly line. You can walk it, but I'd love for you to share your vision from the R22 to what you announced here, the R88.
Sure.
This is a this is a quantum leap forward from where Frank started the company.
Yes.
So could you share a little bit about where the R88 fits and maybe even what's next?
Absolutely. So, I mean, 22, 44, 66 are all constructed out of repairable materials. They have simple construction that is easy to hangar and easy to field support. The 88, we saw a need, and customers came to us and told us they're afraid for their businesses and the economics of running a high volume tourism business or an aeromedical business in the US where the billable rates are capped and they're getting worse. Sometimes the laws make that even harder. So the idea is we want to give them something.
So they're very sensitive to the TCO of every aircraft
they're
running.
You got it. In fact, and the problem is that's been an uncontrollable variable to them since the pandemic. It keeps climbing at a higher and higher rate, right? So I see that as an imperative to move quickly on the 88 and get it into service fast. We'll certainly face our challenges, but we're certainly the most proficient certification in FAA aircraft, and there's no other groups that really certify direct to the FAA for the rotorcraft side at a regular cadence like we do. So we're going to be able to get them fielded. But the idea is these customers want something that is economically simple, economically dependable. So many of the features in the aircraft were intentionally aimed at that the engine Serenity package was aimed at predictability in those early years. So the folks start off.
And it's a turbine engine.
That's right.
Yep.
That's right. And it's actually the world leader in single engine turbines at this point, with the number of aircraft that are being used both in the single light side, but also in twins. A lot of twins that use the Ariel family. Phenomenal engine, one that is uniquely qualified for the heavy utilization missions and the safety critical missions like utility and long lining. Those are not places where you want to have an engine failure. So the engine is a extremely robust package. But yeah, so our vision really is 88's not the end. We are an engineering company. We got a large team of folks, and I want to make sure that once this product gets mature in the development side and we're into flight test and all that, the design team will be pivoting to a 99 or a whatever we call it next after that, kind of running out of numbers. But I do think we'll have projects that will be very similar in this family that go after robust, high performance products, but not overly complex. We won't be, I think in the big picture, won't be pushing the envelopes on technology ourselves because I don't think that's what the industry really needs. The industry needs somebody I was just meeting with guys who own the type certificate for the 214 ST.
Okay.
It's a phenomenal vehicle, great aircraft. I saw that as a young engineer and just how marvelous it is for what it does. There's not enough of those on the planet, and fires are getting harder, and those aircraft are in critical need. So someone needs to help them get that mission satisfied. And so I love connecting with those types of folks.
Can the 88 fit that mission?
It could help. Part of our idea on the 88, and you'll see it today, has a Helitac fire tank on it.
Yep.
And the intention is, I don't think that the model of firefighting today, where the fleets migrate around the planet as fires occur, is efficient or is sustainable. The best solution, because fires happen now worldwide, and there's no fire seasons really anymore. They can occur year-round in many places.
So it's hard to stage everybody to where the fire is.
You got it. So
there's a delay, and it's hard. Delays in the fire season are catastrophic.
That's right. In fact, the Palisades fire near us that happened earlier this year, there was quite a bit of time before they could get aerial assets in place to do the firefighting, and they are ready in California for firefighting. But it was, how do you get them staged? How do you get the airspace properly managed? So I think the key thing for us is that we want to democratize firefighting in a lot of ways. Take the 88, and it's priced intentionally so that it can be a scaled product and be in all of the countries that have firefighting needs. And it can be on the ready. It can be part of a mix of civilian services. That's something that we're really excited about, is that it doesn't have to be a government service that has an asset. We have a partnership with the guys at Operation Hilo that did the hurricane relief work. And we see the need for civilian-born, civilian-driven relief services in some form, where in that case it was delivering supplies and helping take the sick out in an area that you couldn't fit Blackhawks, you couldn't fit Chinooks. Right. So they needed Robinsons to do that. And I think we see that for the 88, that there may be a front line of defense. If it's in my backyard, there's a fire in my backyard, and I have an 88, I want to be able to quickly attach the Helitac tank and drop water to protect my neighbors, to protect the people around me. And I think that's something you could legitimately do with this aircraft, and it's not going to break your bank,
Right. Think you'll have a twin engine at some point?
Yeah, I mean, I think hopefully people see inside the cockpit, they see we've got independent cyclic controls.
Yep.
And I think that's trying to break, one of the things it's doing is it's breaking the idea.
By the way, the cockpit design is quite a far cry from what you have in the 44.
It
is night and day.
We're super excited about it. We are. We have some great folks. My engineering leader spent most of his career at Garmin. He's a commercial pilot himself, and loves what technology in the avionics space has offered, and so I think that's a big part of why you see what you see on the 88. But the idea is we don't want to be considered just a company that does the teetering cyclic, and we obviously we select the controls interface appropriate for the aircraft, and so in this case, it wasn't practical to do the teetering in the 88, nor would it be in a 99 for the same reason. It's too big of an aircraft. The teetering would be kind of a wild-looking monster. So instead, we're not defined by the fact that we've only built singles today. We're doing product right now in the technology space around electrification that is primarily centered on hybridization. And so those are not single-engine aircraft. They are 1 plus a half, maybe, or something. It's not exactly a twin, but we're not going to be defined by a specific part of it. Even the fact that it's a two-bladed rotor doesn't define us. And we have ongoing research and multi-bladed setups. But the customers did not ask for that. In fact, if anything, everything they told us, they want a two-bladed setup. And there are so many people in the world. It's still, two-bladed systems are still the most prolific rotor system on the planet. Jet Rangers, Hueys, Robinson R44s. Those are the 3 biggest products that have ever been built, the largest volume products. And I think if you consider those as all two-bladed setups, it's hard to.
Plus, it sounds cool.
It does. It makes a great noise. And actually, it's funny is the guys in the Hurricane Helene efforts said, that sound, just like it was in Vietnam, that sound means help is coming.
Help is coming.
Right.
That's right.
So.
And let me ask you a question about this. Just as the industry's evolved and advanced air mobility has become at the front of people's mind, and eVTOLs and.
I might have a few opinions on that.
I'd love to know your opinion on where you see that industry going, where Robinson fits in. What does it look like 3, 4, 5 years from now?
Sure. So one of the big things is if you're going to be in vertical lift, hovering is really important, partially because you don't control the end destination airspace. You don't control the departure airspace usually. So you're going to be hovering for some period of time. And I think the best hovering vehicles on the planet are helicopters. That's the same story in my unmanned drones, why we like a helicopter form factor for that instead of the quad rotors in those spaces. I think the attraction for that was always we could just take the success of drones, and there's a lot of drone overlap. People from the industry started the multi-rotor advanced air mobility side, and they said, we'll scale it up and put people in it. And I think that is a oversimplification, and people are prone to that in the world. So we got to always question. And the question I always ask people is, in our product, the number of things that we worry about that are real safety critical elements, the mechanical things are not the things that fail in our aircraft. Particularly, it's shown in professionally managed and maintained aircraft. They are ruthlessly effective at keeping the aircraft airworthy. The problem is pilots either having a bad day with bad weather and sort of improper planning for contingencies.
Congested airspace.
There are some. There's been mid-airs. We have those usually once or twice over a year or so. And so mid-airs are always a worry. We had one last year of 2 R22s in cattle mustering that went into each other. So we worry about those kinds of things. And so technology can actually help a lot with those. Advanced autopilots, advanced perception and avoidance technology, ground collision and avoidance systems, GCAS. These are all technologies that are in the core of what Robinson's doing. So what you'll find on our ships now is every one of them has advanced flight controls built in. So standard on the R66 and R88 will be advanced flight controls that have all forms of protection from envelope protection, overspeed and underspeed protections, low G protections, things that certainly have concerned previous generations of pilot, right? So I think air mobility is doing so many things. The sort of the conventional distributed electric ideas is doing many things to get the topics brought up, but I think it's misguided. And I think my big worry for the
misguided in what way?
Yeah, probably the biggest thing is that I think the scalability of it is not properly thought through. So 2 examples. Carbon fiber composites are great largely in fixed wing applications where you get the benefit over a long flight, 787, those types of products that really benefit from tuned airfoils and things like that. Inherently, vertical lift is going to be constrained because you're compromising speed and range versus the efficiency of a hover. That's something we saw first with sort of the tilt rotor concepts that were developed over at my previous employer. And I think because of that, you add more rotors, you add more complexity, that creates additional failure modes that are maybe not safety critical failure modes, but they are absolutely dispatch critical failure modes. So the ability for an aircraft to arrive on station safely is fine, but if you're dealing with a landing pad in Los Angeles or a landing pad in New York City, and you can't get back off the ground because one of the n number of components fails, which they will, and everything has that same wear and tear. The reality is that that's not going to scale well. And that's why You don't see 8 engines on a commercial airliner. And if you tried, somebody would slap you. If you're a mechanic that has to deal with those, they really rejoiced when you went from 4 to 2. So the better solution in general, and this is a universal reality, is less components that are more reliable. The beauty of the turbine revolution has been that we have now gotten to a point where turbines are incredibly reliable. Mechanical systems, mechanical controls are incredibly reliable.
And the power density, I mean, the
very hard to
design
beat
options,
Jedi.
you can't. Yeah,
hard to beat it. But I do think that's one of the things where I see a benefit long-term in electrification, but it's going to be done best with 1 motor or 2 motors, where you can do it in a helicopter in the large form factor of the lightly loaded, so lower disc loading on the blades is power efficiency. And in an environment where we're looking for sustainability, it is, to me, humorous to look at and say, we're going to be more sustainable, but ruthlessly inefficient in the vehicle design. So I look at it as the guy that has a GMC Hummer electric vehicle. That thing has worse gas mileage than a classic ICE vehicle, but it looks sustainable. So it's the same argument in my mind that we face, is that you want a product that is as simple and efficient as possible. And then if you want to change the source of the energy or the way that it's distributed to the end lift vehicles, I think that's what we're doing in Robinson, is we're going to take the current designs we have, which are incredibly reliable gearboxes made in America, overhauled in America, all done here in our factory, and we're packaging that with a electric motor. And that's, again, one of those small fallacies. There's 1,000 fallacies built into the idea of distributed electric propulsion. And one is the aversion to swash plates. That's hilarious, because I got little swash plates on my drones. They don't cost much. They work every time. Instead, we've got fixed pitch props on a lot of these, or even variable pitch props, but cyclic controls are more efficient, period, for hovering in particular in high winds. You don't want to have to deal with it by differentially thrusting and pulsing and doing all that, right? So the idea is
that's a very complex control system.
It is. I just watched one earlier, and I'd say, like, I watched one take off and fly, and if you get a gust of wind, and these things have to go and kick and then counter kick and then balance and distribute, you're asking a lot of speed controllers and systems that are high voltage electronics that will fail. They will fail, and they fail today every time we've tried. So I'd argue that your better solution is still go back towards what is essential. And the beauty of a helicopter is, even those pieces of equipment, down to the turbine engine itself. The 66 has not had a turbine failure, but if it does, all the pilots are trained to auto-rotate, and that capability is not present in any of these distributed electric propulsion vehicles.
Yeah,
go ahead.
No, I love that. Well, let me ask you this as we wrap up.
Yes.
You guys have had such a great show here and some great announcements, and love what you've shared. Just any final thoughts as we wrap up? And by the way, love to have you back on to a longer interview.
Maybe we can do it after you get a tour of the factory, so you can see how.
We should do it out at Torrance.
You betcha.
We'd actually love to bring my team out.
Yeah, we'll do it.
And with XTI, and actually tour the whole factory.
We love to. We love to. Actually, I tell people, we've hosted probably a dozen advanced air mobility contributors and partners. There are some that are not. They're not trying to bend physics with their tongue, right? That's what people are trying to do, trying to talk past physics. There are some that aren't, and those that aren't are welcome at Robinson. We would share a lot of the lessons we've learned. There's a ton of them. I've met with folks from various parts of the personal air vehicle, the one-seaters that are out there that are flying these vehicles for fun. They're 20-minute, 30-minute runs. I've met with those guys. I've met with several that are in the DEP space that have met. Met with the guys from Horizon.
We just talked.
Yeah, absolutely. Hosted all those guys. And I think we are very, very welcoming. We want to big tent this and get a lot of people in the industry. It's good for us. But I think the important thing is that we all speak out when there are things either unsafe or they're not addressing one of the critical risk factors. And so lack of auto rotation or glide is a really significant one. The difficulty of dispatch reliability. It would serve nobody's interest to have a lot of these product and expensive infrastructure tied up. And so there has to be answers for that. And what's the solution? And is it essential? And all those things. So I think, we're really welcome. We are also very interested in future technology. So if folks have ideas, we're very interested in getting the startup communities and people, to reach out to us, because we're trying to tackle the hard problems of not just designing with latest generation motors and batteries and, hybrid powertrains. We also need to produce them. And so we need partners that have an idea of how to get to our scale. I mean, every one of our product, we don't consider it successful unless it's building 100 a year. So I've got work to do on the R22. So look for future announcements on making the R22 back to 100 aircraft a year kind of product. But otherwise, all of our product doing quite well. So can't make them fast enough. That's what I'd say. So anyway.
It's a good problem to have.
It is. It is. I really appreciate the opportunity. So thank you guys.
Yeah, David, thanks for coming on,
Thanks
man.
a lot. Yeah.
Keep doing great work, and
appreciate it.
I'll stay in touch with you too as I learn how to fly one of your beautiful machines.
Love it. Make sure it's got the new horizontal stabilizer. Tell your guys, and we'll work together to get you a part if you need it. But it makes a difference, and it's also like it is just a better ride, just more comfortable, everything. So get the new stabilizer.
Okay, you got it.
All right.
All right. Thanks, David.
Thank you guys. Yep.